So when it comes to exams, being successful depends on two things. The first is knowing the content, the knowledge. This is what revision is all about. The second is those skills. How do we answer exam questions? How do we approach exams in general? How do we avoid getting moments when you have no idea what to do or getting stuck and running out of time? Okay, so today's session we're going to look at the skills required to be successful in GCSE science exams. Now the strategies we're going to talk about today, there are two. The first one is CUB. Okay, so circle the command words, underline key information and add bullet points. So we're going to use CUB when we talk about longer exam questions. Okay, there's other bits here to CUB as well, reading the whole question, looking does the answer need headings or not, and always looking at the number of marks. But we're going to generally look at these three things and we're going to call them CUB. We're also going to look at calculations as well, and we're going to use something called CIRCAR. Okay, so when we look at calculations, when we answer a calculation style question, we're going to use CIRCAR. So we're going to star what we need to find, underline the values. We're then going to rewrite values with units. If necessary, convert the values, add in the values, and then finally rearrange. These last two in particular are really important. We're going to make sure that we don't rearrange before we add the values, as if we get the rearrangement wrong, we don't get any credit for substitution, putting in values. Okay, so calculations, we're going to use CIRCAR. For longer questions, we're going to use CUB. Now I'm an examiner, and the first 5 seconds of any question is key. Having watched many students sitting many exams in my time, the first 5 seconds can tell me generally how a student's going to do. And I'm going to press these two videos here, and we're just going to compare. The student here on the left is probably going to score a lower mark in this 6-mark question than the one on the right. Okay, and both questions are going to run together. Now what we notice is the student on the left gets off to a flying start. They've already started writing. Chances are they've not really read the question. The consequence of this is that they haven't read the question properly. They haven't really given their brain time to structure how are they going to get the marks. They've certainly not looked at the fact it's a 6-mark question. So compare the particle models for solid, liquids and gases. All they've seen very quickly in that moment before they concentrated what they were doing was compare solids, liquids and gases. So they started writing something about solids. Whereas the student on the right, even though they haven't yet got to the point of starting to answer the question, their brain will be well on the way to a successful answer. They've identified that it's a compare question. They've used CUB, they've circled the command word, it's a compare question. They've underlined key points, it's the particle model for solids, liquids and gases. So this student said solids are harder. That's nothing to do with the particle model at all. And they've identified 6 marks. So circle, underline. They've then written their bullets in before they've started trying to answer anything at all. Okay, and the reason this is useful is just the process of writing the 6 bullets gives your brain time to think, okay, I need 6 different things. So let's have a look at one of the questions. So here's a compare question, and we're going to press play and I'll let you listen to the commentary. Okay, look at the hints on the right hand side. So we've got a number of these questions now where it will show you the question. There'll be a live answer. Remember, circle, underline, bullet. Each bullet needs a different comparison, and comparisons need comparative words. So which one is fastest, strongest, furthest, most or least or cheapest? These are all comparative words.
Okay, so I'm going to compare animal and plant cell. So we're 4 marks. So I've got 1, 2, 3, 4 bullet points. Okay, what do I know about this? Well, if I don't remember the knowledge, I know there's a cell wall. Only plant cells have that. There's a vacuole. Only plant cells have those. And chloroplasts. So I'm going to look at spot the difference first of all. So I have to make sure these are comparisons. So only plant cells. have that cell wall. Only plant cells have chloroplasts. Only plant cells have vacuole. I've got to be careful here to make sure that I say only plant cells, because it has to be a comparison. If I just said plant cells have a cell wall, that's not enough, because I haven't suggested that animal cells do not. I could say here only plant cells have vacuole, animal cells do not. Right, I've run out of comparison. I've run out of differences, so I'm going to pick something that's the same. So both cells have a nucleus. Okay, very straightforward. I've hardly used any of the answer space at all, just used 4 lines. That's how you'd structure a compare question. Okay, so compare animal. Okay, so another compare question. Compare particle models for solids, liquids and gases. Just remind myself what they are. I've got a little diagram there. Might be a solid. Here's my liquid. Gas over here. Okay, so 6 marks. 1, 2, 3, 4, 5, 6. I put all the bullet points in before I start answering. And while I'm doing that, my brain is already thinking of answers, so I can see straight away that particles in solid are closest, because it has to be a comparison. Without that closest, it's not a comparison. Okay. Well, I can do the opposite of that then. Particles in gas are furthest apart. There's no point here talking about solids are hard and gases are not, because I have to talk about particle models. Particles in solid move slowest or have lowest kinetic energy, lowest Ke store, whereas the opposite of that, particles in a gas have highest Ke store because they're moving fastest. Okay, and what else do I know? Well, I know the forces particles in solids are held together much more strongly, much more tightly, are held by strongest forces, because I can't break through solids very easily, whereas the opposite of that, particles in gas have the weakest forces between them. Okay, so again, 6 marks. That in most exam papers, that's about a grade and a half there gained. A very easy question. Most students who answer this, if they don't follow the cub method, will get a maximum of 3 marks. So make sure you follow the cub. Make sure you're going for which is the most of something and which is the least of something.
Okay, so here's a different type of question. This is an evaluate question. And over here, an evaluate is similar to a compare, except you will always have to put a conclusion at the end. So the last 2 bullets on any evaluate question are always your conclusion. I think that because. Now what I'd always recommend here is having for each heading a positive and a negative for each thing. So here, in this question, I'm sure I'll talk about it in just a moment when I go through the answer. The greenhouse frame can be made from wood or aluminium, and the question asks you to evaluate wood or aluminium. So one heading is going to be wood, one aluminium, a positive about each, a negative about each, and then a conclusion, I think that because. So let's see.
Okay, so a different type of question now, an evaluate question. Gives you some information, gives you a table, and then the question comes here. So, and I've changed this question to a 6 mark, even though it was originally a 4. It's more likely to be a 6 in the exam papers you said. So, let's see, it's an evaluate question. So, circle evaluate the use of each material for making greenhouse frames. Use table 9. Okay, that's key, and 6 marks. So, here are my 6 bullets straight away. 1, 2, 3, 4, 5.
Just quickly here before I continue, use table 9. The reason that's very important, because the exam question says use table 9, if I use additional information, even though it might be correct, I'm not going to get any credit for it. I have to use the information that the exam question tells me to use.
And 6. Now I know that in this question, the first 2 bullets are going to be all about, in this case, the materials. I've got wood. So here's my heading, wood. I know I'm also looking at aluminium. So the next 2 bullet points will be all about aluminium. Aluminium. And the last 2 bullet points will be my conclusion. Okay, and by doing that up front, I know people might get scared I'm going to run out of space. Well, that's fine. If I run out of space for this line, get some extra paper if I need it. Right, next thing, because it's an evaluation question, that's going to be positive, that's going to be negative, positive, negative, and these 2 points down here can be something else. So, look at my table. What's positive about wood? Well, I know wood is renewable. That's a positive. Okay? Now, that alone is not enough to get me to top marks. This means, okay, I need to add the so what. This means it will not run out. Will not run out. Okay, also you might think of that word, it is sustainable. There's a word there that you've come across, hopefully, sustainable. Okay, and I'm going to use that because I know it's a bit of extra knowledge I know that might get me a mark. Right, I'm looking for a negative. What's bad about it compared to aluminium? Well, it's heavier. Because I've already used a heading there, wood, I don't need to write wood is, I can just write it is heavier. So what? It might be harder to build with. Okay, because it's heavier. And as I can say, it might be, even if it's not necessarily. Right, aluminium, a positive aluminium. There's no point, I need to stop talking about wood now. I've got 1 positive, 1 negative. Aluminium, what's bad about it? Well, what's good about it? Well, it lasts longer. A longer lifetime. Longer lifetime. Why is that good? Another link word, therefore. You won't need to replace it as often. To replace as often. What's bad about it? Well, what's bad about it? It's non-renewable. It's non-renewable. And why is that bad? So it might run out. Okay, it is a scarce resource. We've only got a certain amount of aluminium on the planet. Okay, so using it, it might run out eventually. Right, conclusion. This is the lovely bit. It doesn't matter what conclusion I come up with, as long as I justify it. But if I don't have a conclusion, I've limited myself straight away to a maximum of 4 marks. So my conclusion, which one shall I go is better? And you can always start with I think wood is better. Just by writing that, I've got 5 marks. Okay, the 5th mark there. Because, now I know there's a bullet point here, I'm going to use it actually, I think this, because sustainability is important. Sustainability is important. And people are more aware of it. Are more aware of green issues, I'm going to say. Okay, so I know that's a little bit woolly, but I've justified it. Doesn't have to be correct, it's just what you think. Okay, 6 marks for an evaluation. Okay, another evaluation question here. Gives us lots of information about 2 types of treatment for kidney disease, dialysis treatment and some information, kidney transplant, some information. It's interesting that this bit's is in bold. I'm not quite sure what, we'll see if that means anything in a moment. And I get down to this, here's the question. So, first thing I'm going to do is cub the question. It's an evaluate question. The use of kidney transplant instead of dialysis treatment for kidney disease. Okay, it's worth 6 marks. So, I'm going to put my bullet points out. 1, 2, 3, 4, 5, 6. My 2 headings, I'm going to start with kidney transplant, kidney transplant, dialysis treatment, then next 2 bullets are going to be that, dialysis treatment, and my last 2 for my conclusion. Conclusion, I need 1 positive about kidney transplant, 1 negative, 1 positive dialysis, 1 negative, okay, and that's it. And I have to use, I've been given lots of information, so I don't really need to know anything about these particularly, because I can get it all from here. So, a positive about kidney transplants. What's going on here? So, let's have a look. Suitable kidney, okay, kidney transplant after the first year of use of that. Okay, a good thing with it is that, well, they tell us costs here. It looks like it's cheaper every year. So it works out cheaper in the long run, doesn't it? Because it's £5,000 a year compared to 30,000. So, positive with that, it works out cheaper because we're comparing cheaper in long term. Why is that a good thing? Okay, this means NHS or whoever it is more money to spend on other things. We have to make sure we add our so what on other things. A negative about it, well, it requires surgery using general anaesthetic. Okay, it also needs a donor as well, so it needs surgery. So I'm going to have both of those actually, surgery and a donor. In fact, I'm not going to add the second, sorry, I'm being greedy. It needs surgery. So why is that bad? This is risky. This is risky for some people. Okay, we don't have surgery unless we absolutely have to. Dialysis treatment, what's good about it? What's good about it is no surgery required. No surgery required. Why is that good? Lower risk for some people. Okay, old people, very ill people, can be much higher risk for those people. And I might say that, e.g., old people. Okay, what's bad about it? Well, you need to do something with it every day for the rest of your life. So need daily. Need daily, weekly treatment. Why is that bad? This is hard to fit in with it. Hard to fit into people's lives. Every week you have to go into hospital for 3 times a week for 8 hours. Okay, so it's hard to fit into people's lives. Conclusion. This is a tricky one here because this one works out cheaper in the long term. This one's better for older people. So your conclusion can be quite complex here. I'm going to say I think kidney transplant. Kidney transplant is better for young people. For young people. Why do I think that? So this is because they are probably better able to cope with with surgery. They're able to cope with surgery. Also, They're able to cope with surgery. Also, it means that they're going to live longer, which means it's going to save more money and have longer lives, so save more money or cost less. Okay, that's the second evaluation question. Quite a tough one, that, but hopefully you can see that all the information is there for you to get all the marks.
Okay, so this question uses circar. Okay, so we got some calculation questions. Okay, you'll notice here that I always add a vertical line down the right hand side. So we're using circar. Add a vertical line down here for all my calculation questions. Okay, and if I'm in any doubt at all, I'll always convert, even if I decide not to use the converted value. Okay, and remember, by following this method, you can get, for instance, with this 3-mark question, it's possible to get 2 marks and actually have an incorrect answer.
Okay, so calculation questions, how are we going to do those? So we're going to use something slightly different now, calculations. We're going to use circar instead. So here what we're going to do is we're going to read through, we're going to star the thing we're trying to find out, underline the values we've got. So I've got a force, 13.8 newtons, 30 centimetres vertically, this thing's been lifted. I'm then, this is the bit that it's always worth remembering, I'm then going to draw a line down there at the side of my page. I'm just going to rewrite those values with their units. So I've got force, F is equal to 13.8 newtons. I've got the formula here, it's been given to me. I've got distance, D is equal to 30 centimetres. Now, the centimetres, I don't often use centimetres in physics, so in science, so what I'm going to use is I'm going to convert that straight away to metres, which is 0.30 metres. Okay, and I'm going to leave that, I might rewrite it right underneath. Now, even if I haven't looked at how many marks this is worth, that has already gained me 1. So it's always worth converting whenever you do these calculations. Okay, I've actually got here as well, I've got there's actually, in terms of command words, if I go back and circle the command words, I've got 2 different things I have to do here. I have to pick the unit as well. So I'll make sure I put that down there, and in this case it's a unit joule. And then I do, the last thing is I've converted my values, I'm going to add in the values. So I've got work done. So work done, I'm just going to use abbreviations here, F times D. And the way I lay it out is really important because I need the examiner to make sure that they give me all the marks possible for it. 0.30 equals, and I calculate that and I write the answer over here, and that's my 3 marks for a calculation. Another calculation question here. Again, this is 3 marks, so it's a fairly simple one. I've got a practical investigate relation with force and extension for a spring, and I've got a set up the experiment there just to help me visualise what this experiment is. You should all be familiar with it, one of our required practicals. I'm going to go down here and, right, what is it I need to find? Calculate the weight on the spring. Okay, so I'm looking for weight, and they give me a formula there as well, which is great. So first thing I do is I've put a star next to weight. I'm going to underline what I've got. It's a mass of 25 grams. Gravitational field strength is 9.8 newtons per kilogram. That's all the values they've given me. I'm then going to rewrite the values with their units, put my line down there. So I'm going to start off with M is equal to 25 grams. Now, that's an unusual value to use for mass, so I'm going to put it into kilograms, which means I need to divide it by 1,000, okay, which gives me 0.025 kg. It's 3 marks. I've already gained 1 mark just by doing that. The next one I've got is gravitational field strength, which I can remember is G is 9.8 newtons per kilogram. Okay, so the next thing I do is I add in the values. So I'm going to, there's my formula there, I'm just going to put it right underneath that so I remember exactly where it is. So weight is mass, which is 0.025 times 9.8. I've got another mark for doing that, and my final mark comes for calculating the answer there, which I'm not going to do right now.
Okay, so here's a complex calculation. Let's see how we approach this.
Okay, so a complex calculation. It's worth 5 marks. It's a big calculation. It looks like we're going to have to do a couple of different things. So first thing is I'm just going to put the star around what it is on it. So I'm going to use circa. Calculate the energy transferred. Okay, so I'm looking for energy transferred by the electrolysis cell in 24 hours. So underline things I know. Current is that. Potential difference is that. I'm then going to rewrite my values. So down the right hand side again, I'm going to rewrite the values so I know current. Current equals 1.5 times 10 to the 5 amps. PD, which I know is a voltage, is measured in volts. V is 4 volts. These are all normal units that I've got here. And time equals 24 hours. Now that's unusual. We don't tend to use hours, so I'm going to convert that straight away. 24 hours, which is 24 times 60 minutes, which is 24 times 60, so that's minutes. Minutes is still a unit we don't tend to use very often, so I'm just going to times all that, whatever I get there, to get seconds. Just by writing that, I've already got one of the marks. Okay, so I've got my number in seconds. I don't know what it is right now, I'll put it in later. Right, calculate the energy transferred by the electrolysis cell in 24 hours. So hopefully we know that power equals voltage times current, and we also know that energy equals power times time. So I've got two different formulas here I'm going to use, and because I've got two formulas, I'm going to put a line down the middle there. Okay, in this one I'm going to work out power. So I know that power equals V times I. And I'm going to substitute in my V and I. I already know what they are. 4 times fuck up there, so I'm going to just do it on the line, equals 4 times 1.5 times 10 to the 5 equals whatever it is in watts. Okay, I've got another mark, maybe 2 marks for doing this already. So that takes me up to 3 marks, maybe 3 marks for definitely. I've then got energy equals power times time. Well, I've just worked out my power here. So I know that energy equals P times T equals whatever this number is here. That's going to go in there. Whatever my time is in seconds is going to go there. And that's going to give me an answer in joules. There. Okay, so the way I've laid it out, I know I haven't used a calculator here to actually calculate what they are, but hopefully you can see whatever this number is here, I'm going to put it in there. This number here goes up there. The way I've laid it out is very, very clear for the examiner to see exactly what I've done, which gives me the best chance of getting the full 5 marks.
Okay, so the last complex calculation question. Let's see how we get on.
Okay, so a complex calculation here. We've got a scary looking set of numbers, and it's worth 5 marks. So straight away I know this is going to be a complex calculation. It's not going to be a simple, just one thing to another. So what I'm going to go through first of all, and I'm going to circa it. So I need to find out where I'm at. So what's the thing? I'll calculate the energy release. So I'm looking for energy. Okay, and I'm just going to write there capital E just so I remember what energy is in my working out. What values am I given? It looks like I'm given quite a lot here. I'm given volume of that. I'm given density of water, which is that. Specific latent heat of vaporization of water is that. Now that's a capital L. Now if I look through, if in doubt here, I look through my equation sheet that I get given for physics, and I find a formula that says E equals mL. Okay, I might not have done that yet because I might, but I always do that if I don't know what the formula is. That's going to be the formula. So I've got L, I've got E, I need to find E, I've got L, I need to find M. Well, these density and volume are related because I know that density equals mass divided by volume, and I've got mass and I've got volume. So jumping ahead a little bit here. I've got my circle, so I've done my star, done my underline. I'm going to rewrite my values first of all. So I'll put my line down the side here, rewrite my value. So I've got V, and I'm going to check the units. V is 2.5 times 10 to the minus 5 meters cubed. That's fine, happy with that. Okay, that's a normal unit. Density, which I know is this weird rho sign there, is 1000 kg per meters cubed. Okay, that's fine. I don't know mass. I know L is equal to 2.26 times 10 to the 6 joules per kilogram, and I don't know E, and that's all the values I've got. Right, I'm going to do two calculations here, one to find out what the mass is, and then to find out what the energy is. So I'm going to split my area up into two. Okay, the first side I'm going to look at density is mass divided by volume. I need to find the mass here. So I've written a formula. First thing I'm going to do is substitute numbers in before I rearrange. Always do that. So I've got 1000 is equal to the mass, which I don't know, divided by the volume, which is 2.5 times 10 to the minus 5. Then rearrange. So I'm going to times both sides by this, and I get mass is equal to 2.5 times 10 to the minus 5 times 1000, which is equal to 2.5 times 10 to the minus 2 kg. Okay, by doing that, I've got another 2 marks. So I've got 2 marks for this alone. Alright, because I've managed to I've put the numbers in correctly, I've rearranged it, and I've got an answer. So I've got a mass now for here, and I know that using my equation sheet, E is equal to mL. So I'm just going to plug those numbers in. So mass 2.5 times 10 to the minus 2 times L, which is 2.26 times 10 to the 6 equals, if you go over a line, just be careful, that doesn't look like, so 106, 10 to the 6. If you go over a line, just be careful to leave a space. Okay, you'll have lots of space going down the page, and if you run out of space, always just ask for more paper. Equals, and I'm not going to worry about calculating that right now, equals something, and that will be in joules. Okay, and that will be my answer, which will go in there. The examiner will look at these questions to try and find if you've done the right things in the right places, but drawing these lines in for them gives them a massive help, means that you're more likely to get the full marks for that question.
Okay, I hope that was useful. Look forward to seeing you soon. Take care.